My name is Lucas Stoneman.
And my name's Aaron Albright.
Today we're going to be discussing the history of astrobiology. There's a few main topics that we'll be going over today, and those topics include history, what have astronomers learned recently, what questions remain, and how are scientists planning to address those questions. Going to history, astrobiology is the study of the origin, evolution, and distribution of life in the universe. The connection of space exploration and exobiology was made by Joshua Letterberg, a molecular biologist turned into an exobiologist. Josh Letterberg and Carl Sagan both collaborated to establish exobiology as a scientific discipline. And the first major expedition for astrobiology research included the Viking Lander project. This was used in investigating Mars' surface for remnants of past or present life.
Astrobiology has led us to have many extraordinary discoveries, two of which are highlighted here. In 2016, the New Horizons satellite flyby of Pluto produced evidence that led researchers to discover that there's a high likelihood that approximately 100 kilometers of liquid water lies under Pluto's surface. This water is theorized to have a similar salt content to the Dead Sea. This evidence was found through thermal models and tectonic evidence that was obtained as a result of this New Horizons satellite flyby. Why this is such a big deal is liquid water is closely associated with signs of life or potential life. Following this theme of liquid water being discovered, Mars was always theorized to have water on its surface and was highly sought after. However, recently, scientists have discovered that liquid water does exist intermittently on Mars and during warmer seasons. This water is likely briny due to the salts on Mars's surface, and this discovery was made through observation of the hydrated materials on Mars' surface and the sampling of perchlorates. NASA researchers focuses on three basic astrobiology questions. How does life begin and evolve? Does life exist elsewhere in the universe? And what is the future of life on Earth and beyond?
All right, so going along with some of those focus questions, we do have some questions that remain. And these questions include, what are the limits of these environments and what kind of extremes could life still exist on? What clues would indicate that a world is habitable, and would the characteristics of an alien world cause life to follow a radically different evolutionary path? Going along with that, scientists are planning to address these questions through a few different things, one of which is through the use of machine learning and AI. Pyrolysis gas chromatography detects subtle differences in a sample's molecular patterns, and that determines if a sample is or is not biotic in origin.
Scientists can also create simulated conditions of primeval Earth to study foundations of life through simple chemical processes. And with all that being said, it leads us to the theme of astrobiology, and that is that astrobiology is an extraordinary science that can lead us to extraordinary discoveries that will require extraordinary claims. And just like Carl Sagan once said, extraordinary claims require extraordinary evidence.